This video will go over Chapter 8 and Section 8.1. So Chapter 8 is on solutions and Section 8.1 is on mixtures. So there is a reminder here about pure substances, which are either elements or compound. And when you have a compound, it can be a covalent compound or an ionic compound. So pure substances are recognized because you are given a formula. They have a set formula, and elements are bounded in a set ratio when you have a compound. But most matter we come into contact with is a mixture of two or more pure substances. And when you have a mixture, it can be either heterogeneous or homogeneous. Let's look at an example of an heterogeneous mixture. For example, here, when you have some pennies in a glass of water, you have a mixture of a solid and water, and you can tell the difference between the two pure substances. So heterogeneous mixture are easy to recognize because we see the two parts when there is only two, and they don't have a uniform composition, so you cannot get mistaken by the fact that there are more than one substance. An homogeneous mixture has a uniform composition throughout the sample, and because of that, it looks like one substance, but you know it's made of more than one substance, so that's how you can classify it as an homogeneous mixture. Brass, for example, is an example of an homogeneous mixture that is a solid mixture of two types of metals, copper and zinc, mixed at the atomic level, but not bonded together. So copper and zinc are very close together. The atoms are packed together, but they are not bonded. They are just very well mixed at the atomic level. And so that's why it looks like one substance, the brass color. So it's not the copper color anymore and not the zinc color anymore, and it's a different metal. And so the color of brass will change, for example, as you change the proportions of copper and zinc in your mixture. So let's go through a learning check to verify this is well learned. So identify each of the following as an homogeneous or heterogeneous mixture. For example, you have a hot fudge sundae. What is this? So a hot fudge sundae is a vanilla ice cream with hot chocolate on top. So you can definitely say that there is more than one substance. So that's easy to say that it's an heterogeneous mixture. Remember how heterogeneous means that it looks different. You can tell the different parts in it. A baby shampoo. So this looks like more like a one substance. It's hard to tell. It's because it's homogeneous. It's hard to tell that you have more than one substance. So this will be an homogeneous mixture. And you know it's not just one substance because it's water and there's a lot of other substances in there. Sugar, water. Again, an homogeneous mixture because it's true it looks like water, but if you taste it, it's going to be sweet. So you know there is more than water, and so the sugar there makes it a mixture, even though it looks like water. So yeah, it looks like water. That's why it's classified as homogeneous. A peach pie is an example of an heterogeneous mixture because you can tell the different parts, like the fruit and then the pie part of it are looking very different. So you can definitely tell you have different things in there, and it's visible. So we classify this as heterogeneous mixture. So now, what are solutions? So a solution is an homogeneous mixture that contains small particles. So it's the name we give to homogeneous mixture. It's synonymous to homogeneous mixture when the particles are small in the mixture. So solutions consist of two parts. There is the solute, and the solute is the substance in the lesser amount. So, for example, when you have salt dissolved in water, the salt, because it's the substance present in lesser amount, is going to be called the solute. And then the solvent is the substance present in larger amount. And when you have a solution made of water and a little bit of salt, water will be the solvent. So this is vocabulary that is important to learn. So solute and solvent are making the two essential part of a solution. Liquid solutions are transparent. Yeah, because solutions are not necessarily only liquid. They can be also solid and gaseous, as you will see in the next slide. But when you have a liquid solution, they are necessarily transparent, which we also say clear. So when we describe a solution as clear, that's what we mean. It's transparent. You can see through it. And so we also heard a lot already about aqueous solutions. An aqueous solution in particular is a solution that has water as the solvent. Aqueous comes from the term aqua, which means water in Latin. So an aqueous solution has water as the solvent. So as I said, solutions can be gaseous, liquid, or solid. And a typical gaseous solution, for example, is the air that surrounds us. The air is mainly nitrogen and oxygen. And then there are smaller quantities of other gases like carbon dioxide and water. But they are all colorless, odorless gases. And so to us, it looks like one gas that is not even really visible. So um, that's why it's a solution, because it's an homogeneous mixture of gases that looks like just one gas. You cannot tell there is more than one gas in air. Um, so the middle illustration here is for an aqueous solutions of NaCl, and that's a typical example of when you dissolve a solid in a liquid. The IV solutions found in hospitals, for example, are all aqueous solutions in general. So you have ions dissolved in water in the case of ionic compound, for example. And then solutions can be solid. For example, the dental fillings used to be made of mercury dissolved in silver. So silver is a solid and mercury is a liquid. They are both metals, but mercury is the only metal that is liquid at room temperature. And when you dissolve it in silver, it makes an homogeneous mixture that is used to fill cavities, and that becomes solid. Another example we had earlier was the brass, right? Brass is a solid solution or homogeneous mixture. So we will go through two more terms or vocabulary that are colloids and suspensions, which are not solutions, but it's another way to classify homogeneous mixtures. So a colloid is an homogeneous mixture with larger particles than solutions would have. So because of that, they are often opaque. So they are not transparent anymore, and you cannot see through them. That's why we say they have an opaque appearance. And so particles in a colloid are larger than in a solution, and they cannot be filtered from its other components. So when you are trying to filter a colloid, everything goes through. You cannot separate the particles by filtration. Another thing is that they do not settle out. They are larger than in solutions, but still they will not settle down. They will stay suspended and as an homogeneous mixture. And so you see the milk here to the right. It's a typical example of a colloid, with an opaque appearance that you cannot filter its component, and that doesn't settle out. It stays homogenized. We are talking about animal milk here. And so a suspension is another type of mixture, but this one is heterogeneous. So be careful, it's not an homogeneous mixture, but an heterogeneous mixture that contains large particles suspended in a liquid. And so the particles in this case are so large that they do not dissolve in the liquid, and they can be filtered away from the liquid or separated using a centrifuge. So they're easier to recognize because they are heterogeneous. You can tell the different parts in the mixture if you let it settle down, especially. And so a typical example here is blood. Blood, if you let it settle down, you will see the red blood cells will be settling more to the bottom than the white blood cells. And that's a property that is actually used to separate the different components of blood. So whenever you have blood drawn from your body, it's put into a tube that is placed in a centrifuge. And then the centrifuge with the speed, accelerate the settling down of the heavier particles to the bottom, and the lighter particles will stay on top. And so the red blood cells will go to the bottom. So you will have that layer of dark red on the bottom of the tube. And then you will have different kinds of layers of white blood cells, because all white blood cells have different densities. So you can tell different layers of white blood cells, and then the plasma will stay on top. And so this way, people who draw blood, they can take the different layers and do their analysis of the blood. So blood is an example of a suspension. So this table summarizes the different type of mixture. So solutions are homogeneous mixtures with very small particles, less than 1 nanometer in size. So there is no settling when you have a solution, and they are transparent, and their component cannot be separated by filtration. Not all solutions are liquid, and therefore a non-liquid solution would not necessarily be transparent. Colloids have larger particle size, from 1 nanometer to 1 micrometer in size. There is no settling still, because it's still small particles. So the component cannot be separated by common filtration techniques either. A colloid compared to a solution will be opaque, will have an opaque appearance. Suspensions are when you have large particles that are larger than 1 micrometer in size, and so there will be some settling. Those particles will settle down to the bottom of the container, and because of that, you can separate them also by filtration or centrifugation. So let's go through a learning check to help us decipher the difference between these three. So classify each of the following as either a solution, a colloid, or a suspension. So first, please pause the video if you want to work this out on your own before you watch the answer. So mayonnaise. Mayonnaise is a A colloid, because mayonnaise is opaque, right? So it's not a solution. Particles are large enough to make the solution, I mean the mixture opaque, right? But if you try to filter mayonnaise, it still stays homogenized, and you cannot separate the component of mayonnaise. It stays very homogenized. So that is a colloid. Seltzer water is water with maybe some gas or ions, but it's clear as water. It's used when, for example, you are dehydrated. And so this is the solution because it looks like water. It's transparent, but you know there are some ions in there. So that's why it's a solution, an homogeneous mixture where you cannot tell that you have particles in there, but you know that you have some. Orange juice with pulp, that's a suspension because the pulp here will settle down and you can see it. So it's very large particles that would settle down, and that's typical of a suspension because this is a heterogeneous mixture. Apple juice. So if you think of the apple juice that you would buy in a store, not the apple juice that you would get, for example, in a farm. Um, so the apple juice that you get in a store in sealed bottles, uh, this would be a solution because typically they are transparent uh, with a color, right? Yellowish brown color, but transparent. And it looks like one liquid, but it's you know that it's not just water. There is it's apple juice, so you know there is more than one substance in there. So it looks like one liquid. That's why it's an homogeneous mixture, and it's transparent, like a solution. So muddy water. Muddy water, if you let it settle down, you will see the mud settle down on the bottom, and then the water will become clearer and clearer on top, right? So that's a suspension because the particles can settle down to the bottom, and you could filter the muddy water and have the mud left in the filter and have more clear water coming out. So that's an heterogeneous mixture, and in this case, it's a suspension. Moisturizing cream, that's you know all those lotions from the bathroom could be classified like that. That's colloids, right? Typically they are not transparent, so they are not solutions. And you know that it's made of many different ingredients or components. So you know it's a mixture and it's opaque typically. However, if you would try to filter it, you know, you would not be able to separate the components. So it's very well homogenized, and so that's a colloid. Fog. Fog is also a colloid. This one may be less obvious, but fog is just in the vapor phase, right? But it's also opaque, right? You cannot see through the fog. Um, it looks like one thing, and it but there are probably other particles in the air that makes it foggy, so it's opaque, so that's why you would call it a colloid, classify it as a colloid. And so that ends section 8.1.